Hey, how are you doing, guys? I'm Bahan. Here is lesson 8, so let's get started. In this lesson, I'll give you a brief introduction to Pandas, then we are going to work with the Tabular module in FastAI, so let's get started with our lesson. Let's begin with an introduction to Pandas. For someone who don't know what is Pandas, it's a library we can use for reading and analyzing any bit of tabular data. And we can do this by creating what is called a data frame. So this can come from a variety of forms, most commonly from CSV files, Excel files, Footer, HTML, JSON, Pickle, SQL, and table. And we will focus on CSV files. And in this notebook, we will use a Titanic dataset. So the Titanic dataset contains information about a subset of passengers and crew members on the Titanic, including whether they survived or not. It's a compilation of demographic, social, and travel-related data that can help us understand the dynamics of survival during that tragic event. So let's take a closer look at it by using Pandas. Here we try to download the dataset, and we will use Pathlib library to read our data. So first we import the pathlib library, then we grab the path and store it in the path variable here. Now let's take a look at what we grabbed. So as we can see that we have train.csv and test.csv file, and we will work out with the train file today. So let's make our data frame. So we can create a data frame by calling pandas.readCSV and pass it the location of the file. And now let's take a look at some common functionalities that Pandas provide. First, we have head and tail. So head allows you to display the first rows of the data frame, and tail will display the last few rows of the data frame. So you can pass in the number of rows that you want to show to each of them, and the default number is 5. And now let's try them. So here we call head and pass it 4, and as you can see here, these are the first 4 rows of the data frame. Then we call tail and pass it 3, and these are the last 3 rows of the data frame. And now let's take a look at different selections that we have in Pandas. So we can select by rows, by value, and even by column. Now let's take a look at how we can select rows. So for rows, there are 2 different ways to select them. First, by using lock. So lock is used to get rows with a particular label from an index. So here we grabbed the rows from 0 to 3. And second, by using ilock. So ilock is used when we want to get rows from a position on an index. And as you notice here, we just grab the first 3 rows from 0 to 2, not included 3. So this is how to select rows. For columns, we can select them by passing in either a string, an index, or multiple columns to select. So here we select the survived column, and as you can see here, we just pass it as an array parameter. To select multiple columns, you can pass in a double array of the column's name. So here we select the sex, the age, and the survived columns. And if we want to pass in the index of the column, we can use ilock. So first you pass it the number of rows that you want to grab, then the index of the column. So here we say that we want to grab all the rows from the first column, and here's the result. And also you can do this to grab multiple columns by indices. So here we grab all rows from the first 3 columns. And the last part for the selection is selecting by value. So to select based on a value, there are a few different ways, most involving a Boolean argument. So here we grab only the female examples, and notice we use lock instead of iLock. And we can do a series of them. So here we grab all the females example that didn't survive. So now we have a general understanding of what the columns are, what the rows are, and how we can select them. Now let's get a bit more advanced. So first we are going to take a look at plotting and how to look at your data. So we can pass in any sort of data that we want and call a plot function, and we can specify what kind we want. So here we plot the first 5 rows of P class column in bars, and we define the title to be P class. And also we can plot multiple columns at once if we want to find some sort of relationship between them. So as you can see here, we plotted the first 20 rows from the survived and P class column, and here's the result. Now let's see how we can deal with multiple data frames. So sometimes we can have multiple data frames of data. So let's take a look at how do we combine them together. So here we split our data frame into two, data frame 1 and data frame 2. In this case, they are going to share some columns. To combine them together, we have merge that allows you to do standard database operations on a data frame or series. So you can pass it the left and right, which is our data frame or series, how we want to merge them together, and what column we want to merge it on. Now let's take a look at the two data frames. So here's our data frame 1 and here's the data frame 2, and as you notice they are shared the name column. So we want to merge them on the name column. And when you choose the column to merge on, choose the unique one. So for example, we can merge on the fair column because we can have multiple examples have the same fair rate. So now let's merge them. Here we call merge and pass it the data frame 1 and data frame 2 and the column we want to merge on. And here's the result. Another option we can do is append, and we can use it if the data frames have the same columns with the same order. So here we grab the first 5 rows from our data frame and store them into df top. Then we grab the second 5 rows and store them into df bottom. And here we append them. In some instances, you want to drop a particular column or row, so you can do this by using drop method. To drop the column, pass it the axis equals to 1. For rows, the axis is 0, which is the default. And now let's go through an example to make it more clear to you. So here we want to drop the survived column, so we call drop, pass it the name of the column, and also you can pass it the index of it. And to drop this column, we set the axis to be equal to 1, and as you can see here, this column is dropped. And here we just remove the first row. And if you notice, when we go back and load our data frame again, we can see the first row and the survived column are still there. Why is this? Because this overwriting your original data frame. So if you want to actually override it, You can pass it in place argument and set it to be true. Now we are going to get into some more complex functionalities. First, we have GroupBy, which is used to split our data into groups if they fall into some criteria. So let's go through an example. Here we group our data frame by if they survived or not. So if we call first, we will see the first entry in each group. So we have two groups, group 0 and group 1, and here's the first entry for each of them. To grab the entire group, we simply call getGroup and pass it the group that we want. So here we grab the group 1. And we can also group by multiple columns. So here we group by both survived and sex. And here's the first entry of them. Next, we are going to take a look at how we can modify our data frame. So we have map. Map is a powerful function that allows us to map values in a particular column to adjust values. For instance, here in survived we have 0 and 1, but that's not something we can read very easily. We will use a dictionary or function to solve this. So here we call map and pass it a dictionary where 0 for dead and 1 for survived. And as you notice, all of our zeros and ones are remapped. Another thing that we can do is to pass it a function if we want to add something else to the string. And the last one that we are going to look at is apply, which is similar to map, except it will just run a particular function on every value in a series. So let's make a basic function that returns if someone survived or not. So it will take a value as an input, and if this value is 0, it will return died, and if not, it will return lived. Here we call apply on survived column and pass it the function. And here's the result. And we can also use an inline function like lambda. So here we pass in some ages and add 5 to them. And here's the results. So in this notebook, I tried to give you a good short of the baseline and a quick way to know what this pandas is. So let's go with the second notebook. Here we are going to work out with a tabular module in fastai, so let's import it. And we are going to work with adult sample dataset, so here we grab it. And here's a list of all the files that we have. Then we make a data frame from a adult.csv file. And let's see its head. So we have age, work class, education, and so on. And we are going to use this dataset to predict if someone makes above or below $50,000. And now let's go with Tabular Pandas. So FastAI has introduced a fresh approach for working with structured data using something called a Tabular Pandas object. This method requires several things: a table of data, certain data processing steps, names of categorical and continuous variables, names of the predicted outcome variables, a definition for how the outcome should be treated, and finally, how to divide the data into training and validation sets. So let's go through each of these components step by step. first, we need to grab our categorical and continuous variables along with how we want to process our data. So here we define a list for categorical variables, which is our work class, education, marital status, and so on, and store them into cat names. Then we define our continuous variables and store them into this variable here. And when we process tabular data in FastAI, we do one or more of these transforms, categorify, FillMissing, and Normalize. So let's go with the first one. Categorify helps to convert the categorical variables into numerical representation using one-hot encoding. So here we make an instance of it. And again here we check the data types of the columns. Here we create a Tabular Pandas object named 2 that holds your data after processing the categorical variables specified in cat names that will be transformed using categorify transformation. And prox here is used to refer to the data pre-processing steps that applied. So if we take a look at trace column, now we have na that fills the missing values in that category column. And if we take a look at more columns, also we have occupation filled with na. And if we call two cats, we can see our one-hot encoded variables. And now let's move on to normalization. To work with our numerical columns, we need to show a relationship between them all that our model can understand. So this is commonly done through normalization when we scale the data between -1 and 1 and compute a z-score. So here we make an instance of it. And these are continuous variables. Now let's go through and apply to our continuous variables. Then we grab the prox. And now let's take a look at that. So we need to grab the means and the standard deviations for our continuous variables. So here's the means of each column. And here's the standard deviation of them. And we can also call two const to take a look at our transformed data. So as you can see, all of our data are transformed. And if you notice, we have that none, which tells that this field is missing. So let's see how we can solve it. So we are going to solve it by using the last preprocessor, which is called FillMissing. And this takes care of any missing values in our continuous variables. Only remember we have a special na category for categorical variables. So we have three strategies we can use to fill the continuous variables. We can fill them with median or constant or mod. Here we create an instance and we are going to use a median to fill the missing value. So here we define the fill strategy to be median. Then we recreate the tabular pandas. And if we take a look, we don't have this nan anymore, so all the missing values are replaced with the median. Now let's build our tabular pandas. First, we randomly split our data and we define the range of our data frame. And if you want to know what is the range of, it grabs all the indices that are in the data frame. Then we define the categorical variables, the continuous variables, the pre-processing that we want. Notice here we use categorify, FillMissing, and Normalize. And the name of our y variable, which is the salary, and what kind of block we want for our y value, which is in this case is category block. Now that we have everything declared, let's build our tabular pandas. So here we call the tabular pandas and pass it the data frame and all the stuff that we have defined in the above cell. Then we can build our data loaders. We can do this by using one of two ways. The first one is a straight one. So here we just call .DataLoaders and we can show a batch of it. So this is the first way, it's so easy. And the second option is to create two data loaders. We can make special loaders for our data, one for training and one for validation. Doing it this way is helpful because we can easily choose the batch size, whether or not to mix up the order, which is a shuffle. So how do we use these loaders? Right now our training examples are in toTrain and our validation examples are in toValid. We just tell the loader which data to use and what the choices we want. As you can see here, our train loader need to be shuffled and the batch size here is 64, and for validation loader we want the batch size to be 128. Then we just call data loaders and pass it our two data loaders, the train data loader and the validation data loader. Then we show a batch of our data. Now we can build our model. When we're dealing with our categorical data, we need to create what is called an embedding matrix. This allows for a higher dimensionality for relationships between different categorical cardinalities. First, we have getEmbeddingSize. The purpose of this function is to determine the default embedding sizes for categorical variables in a tabular dataset. If we go through it, it takes a Tabular Pandas object, an optional dictionary that contains custom specified embedding sizes for certain categorical variables, and the function will return a list of default embedding sizes. Each size in the list corresponds to a categorical variable's default embedding sizes based on its number of unique classes. And as you can see here, we have one embedding size. So for one embedding size function, first it checks if we have a dictionary, then it grabs a number of categorical features and then goes ahead and calculates the rule of thumb. And here's the code for the rule of thumb. So the function returns the minimum between 600 and the result of rounding 1.6 multiplied by the cardinality raised to the power of 0.56. Then we grab the embedding sizes. And here's the result. So if we take a look at the first one, we have 10 by 6. So it got embedding size of 6, and this corresponding to the worker class variable here. And if we take a look at the number of unique values that it has, notice here we get 9 and in the above cell we got 10. This because here doesn't take into account the missing values, which is the net category. For numerical, they just numbers, so we can pass them straight into the linear layer. And now let's go through and build our tabular model. But first, let's take a look at what makes this model a little different is our batches is actually two inputs. So here we grab one batch. And if we take a look at it, we have two tensors, one for the categorical variables and one for continuous variables. And when we build our model, we need to pass in our embedding sizes, the number of continuous variables, the number of outputs that we're expecting. And this 200 and 100 here is how many fully connected layers that we want to use. So if we go ahead and build our model, you can see first we have our embedding matrix, then we have the dropout, our batch norm 1D, then the sequential layers, and for the last layer we have the input is 100 and the output is 2. So now we know the background. Let's use the TabularLearner, which does all of that for us. Here we passed the data loaders some sort of layer size to use and the metrics. Now we can find the learning rate and fit for 3 epochs, and if you notice here we get around 6 seconds. So can we speed it a bit more? So the answer is yes. The more you can load into the batch, the faster you can process the data. So this is a careful balance. First, let's make a batch size of 1024. Then we build our TabularLearner again. And the learning rate graph here looks a little smoother, and that's not good. And if we fit for 3 epochs, we get close to the accuracy, but it took a less time. And now let's see if we try to increase the batch size too high. So here we will use a batch size of 4096. As you can see here, we have much different learning rate. And now let's fit and see what happens. The accuracy is decreased. So the ideal scenario for this problem is to use a batch size of 1024. Now let's look at inference. So here we are going to export and load back the model. And once we load our model, we can create a test data loader by calling learn data loaders test data loader and pass in some data to use. And if we show a batch of the data, as you can see here, we have the y values that the model should go and predict them by itself. Now let's go and remove them by using drop method. So here we call it and pass it the salary column that we want to remove. So if we go and try to call validate on it, we get none because there is no labels here, there is nothing to compare to. But if we build a data loader that has the labels, then we call validate on it. As you can see here, we have the accuracy. So we have covered a lot of things today. So that's it for today's video. Hope you enjoyed.